Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss free electrons, means Fermi gas in metal. Let's begin. Free electrons or Fermi gas in metal. What is Fermi gas? Fermi gas is the ensemble of fermions, means the collection of fermions are called Fermi gas. In case of bosons, the collection of bosons we called Bose-Einstein gas. Similarly, the collection of fermions are called Fermi gas. When we are dealing with metals, in case of metals, there are free electrons, and these free electrons are randomly movement throughout that of metals. So, since fermions are those particles having spin integral multiple of odd integral multiple, means either it is half, 3/2 or 5/2 like this, and they obey Fermi Dirac statistics and also Pauli exclusion principle. In this way, the metals, there are free electrons. These free electrons move freely without any collision, similar to the molecules of an ideal gas. When we consider an ideal gas in a container, the ideal gas are movement inside that of container freely. We relate that ideal gas inside a container to the free electrons across that of metals. Hence, these electrons are known as free electron gas, or we call it as Fermi gas or free electron cloud. As we taken these free electrons in that of metal, and these free electrons are called as the Fermi gas. So, by using Fermi Dirac statistics, we can easily derive the expression for energy distribution among these electrons, that electrons present in that of metal. From Fermi Dirac statistic, Fermi Dirac statistics, the energy distributed among the particles, means energy distributed among fermions, Ni is equal to Gi divided by e to the power alpha into e to the power ui divided by kt plus 1. We divide the entire system into k number of compartments. From here we choose ith compartment. The number of particles inside that of ith compartment is Ni, and that ith compartment is further divided into Gi number of elementary cells having equal size. Alpha be the constant, beta is the another constant, and its value is 1 by kt. That be the expression for Fermi Dirac statistics, energy distributed among fermions. Therefore, by using that relation, we can say what be the number of electrons, the number of electrons having their energy range between U and U plus du is given by, within this energy range what be the number of electrons. As we say, electrons are under the category of fermions, identical indistinguishable particles. The number of electrons within this energy range is written as n u du is equal to g u du divided by e to the power alpha e to the power u divided by kt plus 1. Equation number 1. What is GU du? GU du is the number of phase cells within that energy range U to U plus du. To calculate GU du, we have to calculate what is GPdP, means number of such phase space cells within a particular momentum range. Now, the number of phase space cells in between the momentum range P and P plus dP is given by, within this momentum range what be the number of phase space cells, that is Gp dP is equal to, that is total number of volume available in that of phase space divided by volume of each cell, total volume available, phase space cell, the position coordinate, the momentum coordinate, 3 position coordinates, its volume as triple integration of dx, dy, dz, again triple integration of momentum dpx, dpy, dpz divided by volume of each cell hq, triple integration of that of position coordinates as the volume of that of system capital V into its the triple integration of that of momentum coordinate is 4 pi p square dp. That derivation we have already done. We just write the values here. So GPdP, number of phase space cells within that of momentum range is now calculated. But for electron having plus half and minus half spins, so two types of electrons in that of system, and these are distinguished from each other. Distinguished from each other. On their spins. As we say, fermions are identical with indistinguishable particles. So, these two spin electrons, one having plus half, are treated as one system, another spin of electrons minus half also treated as another system, means the entire system is divided into two subsystems. Therefore, to show electrons as identical with indistinguishable the entire system is now divided into two subsystems and the number of phase space cells within this momentum range will be twice. Okay. So, Gp dp is equal to 2 times of V into 4 pi p square dp divided by hq, or Gp dp is equal to V 8 pi V p square dp divided by hq, that equation number 2. But our requirement is to find out Gu du. To calculating Gu du, first we define energy in terms of kinetic energy. In order to calculate Gu du, we define the energy U in terms of kinetic energy. That is U is equal to half mv square. Kinetic energy in terms of momentum, so half 1 m is multiplied and divided both numerator and denominator part, half mv, that is p square divided by m. Therefore, p square is equal to 2 mu, or p is equal to 2 mu under root. Now differentiating we get dp is equal to 2m under root as constant, under root of u as half u to the power minus half into du, or dp is equal to root 2 1 root 2 here. So the term is written as m divided by 2u under root du. The value of p and dp now putted in that of equation number 2. So equation 2 becomes, therefore equation 2 becomes gu du will be, the values are putted, 8 pi v divided by hq 2 mu instead of p square, 2 mu, instead of dp m divided by 2u under root du, or gu du is equal to 8 root 2 pi v m to the power root 2 half plus 1 3/2 u to the power, similarly half divided by hq du. Equation number 3. The value from equation 3 is putted in equation 1. We have in equation 1, that is the expression for number of electrons within this energy range. So nu du is equal to the value of gu du 8 root 2 pi v m to the power 3/2 divided by hq into u to the power half divided by e to the power alpha into e to the power u by kt plus 1 du. This is the expression Fermi Dirac law of distribution of electron energies. Fermi Dirac law of distribution of electron energies. How energy is distributed among these electrons, and these electrons are present in a metal. So, here with the help of this video lecture we understand the concept of free electrons, which is called Fermi gas in metal. What is Fermi gas and how that free electrons are comparable with that of ideal gas in a particular container. By using Fermi Dirac statistics, we calculate what will be the number of electrons within this particular energy range. Next, Gu du is calculated by taking Gp/dp in a particular momentum range. Next, as we consider electron, those are fermions having half minus half spins. So, they are treated as two kinds of distinguishable particles. To show these particles under indistinguishable, we taken the entire system into two subsystems. Therefore, 2 is multiplied in that particular equation. Next, to calculate Gu du, first we have to define kinetic energy in terms of momentum, differentiating it, the value of dp and p square is put in that of given equation, and Gu du is calculated. Finally, the value of Gu du is put in the expression number 1, that is the number of electrons in a given energy range. That one is the equation of Fermi Dirac law of distribution of electron energy. So, with this useful and informative notes, let me wind up the session. Thank you.